So you might be wondering, what do we need a differential amplifier for? So first I'm going to draw a circuit here. It's something that you might have seen before. It's called a Wheatstone bridge circuit. So it's really just 4 resistors like this, and it's a classic circuit that's used to make measurements. And it's 4 resistors. It's connected to a power supply between the V positive and the negative, or the ground right there. And if you have, say, 3 resistors with known values, and then one with an unknown value, you could use the circuit to figure out that value. And part of the way you do that is you sense the voltage at these 2 nodes right here, and you look at the difference in the voltage. And in order to do that, you'd use something called a differential amplifier, which amplifies only the difference. The reason that's significant is that we don't want to amplify the same signals or the common mode signals, only the difference signals. So if you look closely at the circuit, it's actually 2 voltage dividers. There's one on the left and one on the right. And if the resistance here changes, then obviously the potential on this side is going to change. So you can get a ratiometric measurement, basically, because this is a voltage divider. As this resistor changes here, as it gets larger, voltage there will go down. If this resistance here gets smaller, voltage will go up. So the reason for the branch on the left-hand side is because sometimes the power supply fluctuates. Like you can imagine, if it's not perfectly stabilized, then this voltage here could change from something other than the unknown resistor changing. So by having a fixed set of resistors here, or a fixed voltage divider, if the voltage supplying this changes at all, it's going to affect both of these in a similar manner. Like, say, if the voltage here goes down a little bit, voltage at that node will go down, and the voltage at this node will go down. So if we're only measuring the difference between these two, then we're going to null out these effects right there. And to do that, we use something called a differential amplifier.